Imagine. Okay. Stay with me now. Imagine something so powerful that if it were to even be just a few hundred light years away from us, life on Earth would cease to exist, cooked and sterilized by a singular celestial body and its radiation. That object is Ton 618, one of the largest and brightest quasars ever discovered, powered by a black hole tens of billions of times the mass of our Sun. In this video essay, we're going to explore 5 main questions. 1. How could Ton 618 grow so massive so quickly in the early universe? 2. What made gas so much more abundant back then compared to today? 3. Why did the low metallicity of the early universe matter? 4. Will the Milky Way become a giant black hole after colliding with Andromeda? And 5. What makes Ton 618 so terrifying? And why are we lucky it's unimaginably far away? But first, we need to set the stage in order to properly understand Ton 618. To set the stage in order to properly understand Ton 618, we need to demystify a few terms. What is a quasar? So a quasar is what happens when a galaxy's central black hole feeds on matter. As gas falls inward, it forms a hot swirling accretion disk, radiating across the spectrum from radio waves to deadly X-rays. Some quasars are so luminous, they can outshine thousands of galaxies combined. Ton 618 is one of these. Well, how do we measure that? We usually measure black holes using solar mass, or rather one of the sun's worth of mass. For context, our Milky Way's black hole, Sagittarius A, is about 4 million solar masses, whereas Ton 618 is around 66 billion. Whoa, that's massive. Do black holes even got a limit? Well, another important concept is the Eddington limit, which basically describes the maximum rate at which a black hole can grow, balancing gravity to pull gas in, and with radiation pushing it back out. Ton 618 seems to have pushed or even broken that boundary in its youth. So, how do you build a monster like this? Firstly, seeds. In the very early universe, some black holes may have started not from stars, but from the direct collapse of giant gas clouds. These seeds could have amassed to be 100,000 to 1 million solar masses right from the beginning, giving them a massive head start. Secondly, gas supply. About 10 billion years ago, the universe was denser. Galaxies weren't starved for fuel like today. Instead, they were fed by cold streams of hydrogen gas, funneled directly along cosmic filaments into their centers. Simulations show that these streams could bypass the heating and turbulence of that usually choke-off supply, letting black holes binge, consuming mass for millions and millions of years at a time. Thirdly, low metallicity. The early universe had barely any metals, being mostly hydrogen and helium. This meant gas clouds cooled less efficiently and resisted breaking apart into many small stars before collapsing suddenly and entirely into a truly massive celestial object, as less fragmentation meant more raw material going straight into the black hole. And finally, super Eddington growth. For short bursts, Ton 618's ancestor may have grown faster than physics textbooks once thought possible, allowing matter in more quickly than radiation could blow it away. Together, these factors meant that just within a couple billion years, Ton 618's black hole ballooned into tens of billions of solar masses. To put it in perspective, Ton 618 is about 15,000 times more massive than Sagittarius A, which is the black hole at the center of our galaxy, and hundreds of times more massive than even the biggest black holes found in local galaxy clusters today. Ton 61's accretion disk shines with about 4 times 10 to the power of 40 watts, which is 4 followed by 40 zeros, which is more than 1 trillion times the luminosity of our Sun. But could such a monster form today? No, almost certainly not. The cosmic buffet is gone. Gas reservoirs are thinner, galaxies are more metal-rich, and supernova plus active black holes inject turbulence and heat into the surroundings, choking off easy feeding. Even entire galaxies colliding, like the future Milky Way Andromeda collision 5 billion years from now, couldn't create something similar to TON 618. Yes, they're central black holes, one with 4 million solar masses, the other with about 100 million, will merge. And yes, the result will be impressive, but still nowhere near tens of billions. If the mass of the entire galaxy was to collapse onto itself, it would be bigger than TON 618. But the physics just don't work like that. Okay, so with most of the fun stuff out of the way, let's indulge the math heads for a moment. The sun's irradiance at Earth is about 1,360 watts per square meter. TON 618 has a luminosity of roughly 4 times 10 to the power 40 watts. If you apply the inverse square law, the distance at which TON 618 would deliver the same irradiance as the sun is about 160 light years, which can be calculated with this equation, which is F equals L over 4 pi d squared. Besides all the numbers, that's pretty frightening, because unlike the sun, TON 618 emits much more high-energy UV and X-rays. As mentioned earlier, at 200 light-years, Earth wouldn't just get extra sunlight. It would be bathed in sterilizing radiation, stripping ozone from the atmosphere and frying life on the surface. All while at that distance, it would still have about half the gravitational strength of the sun, pulling us, as in the sun, Earth, and all of the other planets in our solar system towards it. So let's recap. TON 618 is a cosmic relic of an age when the universe was denser, simpler, and much more violent. Its black hole likely grew from a massive seed fed by rivers of cold gas that spanned epochs, allowing by this low metallicity of its time, all supercharged by bursts of runaway accretion. Today, such conditions don't exist. Our own galaxy, even after merging with Andromeda, will never rival this scale. And yet, TON 618 still shines to us across 18 billion light-years of space as a monument to the extremes of physics, a cosmic entity born at the beginning of time, something so powerfully huge that its creation today would be nothing short of an anomaly, as only the young universe could make such a monster.